I want to talk a little bit more about reflection and specular and diffuse reflection in particular. And to start off, I want to make a minor correction to the last video. And it's actually an interesting correction because in this image right here, when I talked about a double reflection, I talked about the light from the sun hitting this pond or specularly reflecting off of the surface of this pond and then reflecting off of this paddle to get to our eye. And when I said where the light ray was passing, I said in the last video, I said it goes from the sun to this point on the surface, because that's where we saw the reflection. And I said then from that point to this point on the paddle and then to our eye. And the correction here, and someone pointed this out on the message board, and it was a very good catch, is that this point is where the light is reflecting to our eye. So, and that's because we see it. We see the sun there. So this light right here is coming directly to someone's eye. Let me draw someone's eye right there, or our eye. Our eye is kind of coming straight out of the page. The light that got reflected here is going to be reflected a little bit more shallowly. So it came from the sun. It came from the sun. And obviously, won't be exact, but it came from the sun. It probably had a slightly more shallow angle of incident, or angle between the ray and the surface, and then it would have gotten to the paddle. Then it would have gotten to the paddle, and then it would get to our eye. And I want to make clear, we don't see the sun at the point that it was reflected, because that light, that image of the sun, is going to the paddle, which then goes to our eye. The point that we see the sun, the reflection of the sun, that light's going straight into our eye. It wouldn't have to be reflected by the paddle. So that was an interesting and good catch when you think about the double reflection. The other thing I want to talk about is when you have both specular and diffuse reflection happening at the same time. And we see this all over the place. Anytime you see kind of a shiny object, something that's not a mirror, but it's a shiny object. And we see that right here in the apple. And just to make this clear, so you can see this white part right here, which we've all seen on a nicely waxed apple, it's like a reflection of the actual light source, while everywhere else it's just kind of the color of the apple. And let's think about what's happening here. So if I were to draw the surface, of the apple, I'm going to draw it in a neutral color. So let's say we have the surface of the apple right over here. We have the surface of the apple right over there. And then maybe I'll draw it as a slight circle, just so that you can appreciate that it's a circular apple. So it's the surface of the apple right over here. You have some light source. So you have some light source. So you have some light source over here. And it's emitting light. So it is emitting light in some direction onto the surface of the apple. And what's happening on the surface of the apple, there's a couple of things that's happening. You're having some of this light is reflecting specularly, or another way of thinking about it is it's maintaining the image a little bit, but not all of it. So let me just draw it. So if you're coming in at that incident angle, you're going to leave at that reflected angle. And if you came in at this incident angle, you're going to leave at that reflected angle. And if you came at this incident angle, you're going to leave at that reflected angle. And I'm doing dotted lines to show you that it's not all of the light that's getting reflected that way. Only some of the light is getting that specular reflection. But if this light were to be reaching your eye, let me draw a proper face. So let's say that this is someone's face right here. That's their ear or their hair, that's their eyebrows, that's their mustache. I think you get the general idea. So this person will see a reasonably good version of the light source, which we see right over here. But what's going on the rest of the apple, or even over here, so some of the light is reflecting specularly, is kind of maintaining the image of the light source, although that's also getting distorted a little bit. But the rest of the light, and let me be clear here, some of it is being absorbed. Some of it is being absorbed by the actual surface of the apple, but the rest of it is reflecting red light. What we see is actually what the apple does not absorb, what the apple is reflecting. But that red light, that mainly red, I mean it's a bunch of different shades over here, is reflecting diffusely. So that pure light comes in here. Some of the pure light gets reflected specularly, or kind of purely maintaining the image. But some of it, because the surface of the apple isn't smooth, is going in all sorts of directions. So some of it's going like that, some of it's going like that, some of it's going like that. And that's happening at every point on the apple. So that light source, let me draw more of the light source. So rays coming in from our light source, but every point of the apple is also having this diffuse reflection, which is reflecting only the red part of the spectrum. It's absorbing all of the other parts of the spectrum. And so what you see is that point where you're getting the pure specular reflections, that's the point that looks shiny, where you can kind of see the light source. And from every other point on the apple, where only this guy right here is only getting the diffuse red light. And that's why if you move the apple, or if you're actually even better, if you move where you're looking at the apple, that point of reflection is going to look like, if I start looking from this direction, I'm going to get a different point of reflection, because I'm going to start seeing the light. Let's say that someone's eyeball is actually right over here. So that's their eyebrows, that's their eyeball, that's their nose. You get the general idea. So let's say this person, that's their ear, I don't want to get too involved in drawing. But let's say that this person is looking at this super ginormous apple now relative to him. He's not going to see this white spot there. He's going to see the white spot on the point where it looks like where he's getting the right angle, where the rays are coming in. Let me do it in a different color. So let's say the light source is above us. So the light source is coming straight down, to the apple. And then if it's the right angle, if the angle of incidence and angle of reflection relative to the surface of the apple, and we can draw that out. We can draw perpendicular to the surface of the apple. This is the angle of incidence. This is the angle of reflection. So at those points, at that point right there, he's getting a little bit, and I should draw a dotted line. He's getting a little bit of the specular reflection. But from every other point, so for every other point on the apple, so over here the specular reflection would go that way, not to his eyes, or it would go that way, not to his eyes. But from those points, you also have some of the diffuse reflection. Some of that is going to his eye in terms of red. The red part of the frequency is getting to his eye from all of these other random directions. And that's why this guy over here, he would see this reflection. He would see this reflection roughly over here, and all of this other part of the apple would look red. Since we're on this side of the apple, we see the reflection point. The light is coming straight down from our light source, bouncing right here, and then coming straight out towards our eye. Coming down and then reflecting, coming straight out towards our eye. It's also coming down on these other points. But those other points are going straight out to some place where our eye isn't. And instead, we're just seeing the diffuse part that is actually coming to our eye. Anyway, hopefully you found that a little bit more, filled in a couple of the gaps of the last video.